All right. Hi, everybody. My name is Alex Houghtaling with LineVision, and I'm pleased to be with all of you today to hear from true industry experts in the energy field, each of whom I think has a scary level of accomplishment in their respective fields, but perhaps most importantly, as you'll hear on this webinar, has individual informed opinions about the issue at hand. And that's what I think is going to make this a really interesting call. These are the people who are shaping our understanding of the macro trends in the transmission space, and we're thrilled to have them with us here today. We're going to discuss line ratings for 2021 and beyond, but as with any topic of any consequence, no one issue exists in isolation. LineVision, for example, doesn't monitor conductors just because utilities want better information. We do it because utilities face inherited, never before seen problems, and I'm sure you're all familiar with several of these. We know that the growth of renewables is relentless, and as a country, we face $8 billion a year in congestion costs. 50% of the conductors that are hanging from your towers are at or near the end of their useful life. And we've already seen the first utility bankruptcy from wildfire and climate risk. The level of transmission attention that we're receiving is certainly reassuring. And the recent FERC NOPR, which we're here to discuss today, really underscores that. So let's jump right in and talk about the FERC NOPR. But before I do, one item of note, the thoughts, the perspectives and the opinions that we'll be sharing on this call from LineVision and from our esteemed speakers are, of course, just that. They represent no legal advice. They represent nothing more than our perspectives. And so should you have questions, please consult your individual counsel for any FERC related guidance. All right, let's jump into the NOPR itself. So something that's important to be aware of is, first, why is FERC taking this action? And through our lens, we see this as a means to deliver more capacity to the grid with less risk. So we understand the challenges with congestion that exist at the macro level, and our speakers will be addressing those challenges today. Ambient adjusted ratings, dynamic line ratings, advanced line ratings in general are designed to address the capacity and congestion challenges that the grid faces. But risk is also a factor. The ability to use advanced line ratings in a smart way to make sure that for those few instances where advanced line ratings actually fall below static ratings, that we're not doing damage to our conductors. Advanced line ratings can help both with the upside and the promise of more capacity, but also address resiliency and the need for a strengthened, strong, reliable grid. The FERC NOPR, oh, sorry, John, next slide, please. The FERC NOPR that we're discussing, as many of you probably have already heard, was discussed on a call on November 19th of last year. And it has not yet been entered into the Federal Register, but at the point it does, it will kick off a 60-day period for public comment. So once that has been launched, I'm sure many of you on this call will be making your comments, which is great. And then FERC will aggregate and organize those comments, and then we'll announce a decision about the path forward. Next slide, please. Okay, so what does the FERC NOPR require? So first, it's looking at ambient adjusted ratings as a mandate and saying for any line that has posted congestion in the past 5 years as of the date of entry into the Federal Registry, that you will need to do at a minimum ambient adjusted ratings on those lines. So that would include anything at or above that classification. So dynamic line ratings would count, and of course, ambient adjusted ratings count as well. After a year, it's not just going to be for any lines that have posted congestion, it will be for all lines. So really, this is an integrated approach, a step-by-step path toward having more capacity available on the grid, which is important and ultimately is going to address some of those challenges. Next slide, please. In addition, and this is also, I think, signaling something crucial as well, RTOs and ISOs are going to be required to be able to ingest hourly data for advanced line ratings. And specifically, they're going to need to look at a 10-day rolling ambient adjusted rating updated hourly. So bottom line is 10 days times 24 hours, there will be 240 hours. So 240 individual line ratings that will need to be updated on an hourly basis. And of course, LineVision is able to help you achieve that, whether it's with ambient adjusted ratings that we're able to help you deliver or dynamic line ratings as well. We're also able to help with NERC FAC 83 compliance, because that is a standard that will be applied to this as well. Next slide, please. Some of my thoughts around the importance of this and the distinctions between ambient adjusted ratings and dynamic line ratings. Rob will be getting into that shortly, but really at a high level, some things to note if you go through and read the NOPR itself is that there are quite a few mentions of dynamic line ratings as well. Specifically, you can see some of the quotes on this slide. DLR is shown to be more accurate. So it's my opinion that the stepwise approach that we're seeing from FERC with ambient adjusted ratings is really leading us to a place where we will arrive at the ability to have dynamic line ratings incorporated into the grid. And again, we'll get into some of the technical distinctions between those terms in a moment. As I mentioned earlier on this call, DLR can sometimes be lower than ambient adjusted ratings or the static line rating for that matter. And so there really is an emphasis on the safety of your transmission lines and the security of the system as well, insofar as adopting these advanced technologies will give you the ability, again, to of course have the upside of more capacity, but also reduce the risk associated with those moments where the actual advanced line rating falls beneath the static line rating. And of course, deploying DLR sensors delivers additional benefits as well. LineVision's particular sensors are able not just to deliver advanced line ratings, but conductor asset health information and real-time situational awareness. So I think it's also important to note that in FERC making mandates around using advanced line ratings, there's also the potential for great upside in terms of deploying technology to be able to increase and enhance your understanding of your conductors and the grid at large. So we think this is a very positive development. Obviously, there is a lot of nuance to this, and since the final version of the NOPR or the proposed rule hasn't yet been released, we'll see what comes with that. But I think we're getting some really good direction, even at this stage, with respect to what we can expect, because look, we understand a lot of the challenges that exist, and I'll introduce Nora in a moment to be able to talk through some of those macro level challenges. But this is a year of transmission. We're going to see, I think, within 2021, a lot of positive advancements in terms of making the grid more resilient, safer, and with higher capacity. So at this point, I'd like to introduce who I would like to call my colleague, Nora Mead Brownell, who is a former FERC commissioner and chair of the board of Pacific Gas and Electric. She is also the founding partner of SB Energy Solutions, and she is also a member of LineVision's advisory board, which we're very pleased with. You know, I have to say about Nora, looking back over her career, some people wear glasses, others see through telescopes, and I think that Nora's time within FERC and within her career can really be accounted for with looking through a telescope, specifically the role the grid would play in the future in optimizing renewables and asset management and planning data. So she's always been focused on upgrading the grid for what's next, what's coming. And as we have now reached a point, I think, where transmission capacity is really front and center with this FERC NOPR that we're under discussion now, that focus of Nora's, I think, has certainly been prescient to say the least. So very pleased to turn it over to Nora for her thoughts and comments on the NOPR and the transmission system at large. Nora.
Great, thank you so much. Could you record that and send it to my children, who actually don't think me prescient? They think I'm really boring because I get so excited about the grid. The reality is it's lovely to, after 25 years, to see people really paying attention to this, because transmission has been sadly the ugly stepchild of the system for way too long. And I'm thrilled that we have moved into a new energy economy, but we forgot a very important part of that, and that is the grid and the ability to deliver on the promise that we've seen. Certainly 25 years ago, we actually had incentives before EPACT 05, and the whole point of those incentives was not only to create broader participation in wholesale markets, but there was a lot in there about investment in technology. And unfortunately, that kind of went by the wayside, but FERC is now really laser focused on the grid itself. And this is a terrific first step. I commend Commissioner Clements, whom I heard speak a couple of days ago, who really talked about opening a real look at not only the markets, but at transmission planning. So I think the kind of technologies that we're talking about and the ability to do more accurate and realistic line ratings brings so much value. Alex, you've talked about some. It sends the right economic signals so that both upside and downside of congestion costs, we're really sending the right signals. It allows us to plan so much more efficiently. Every part of our economy has been dramatically changed by the ability to make more data-driven decisions. And this absolutely provides us with data that not only gets to those economic signals so we get the right allocation of resources, but it allows us to see and manage very differently, far more efficiently, and bring value not only to optimize renewable assets, to support the electrification of our economy, but it also brings value to the customers, who are often the last people to be considered, but who ultimately pay the bill for all those inefficiencies. In addition, this kind of data and transparency allows us to manage through extreme weather conditions. And having lived for a year in the bunker at PG&E, I can see firsthand how important it is to bring this transparency to manage assets in a very different way. This will give us real-time information about those assets because they're behaving not necessarily according to manufacturers' best estimates, but because of the extreme conditions in which they're operating, we can no longer count on kind of the static view of asset life. So I think this helps with reliability. I think it helps with efficiency. I think it optimizes renewables. I think it brings data that will inform a lot of decisions, including those which we invest in, where we invest, and how we invest. Transmission is almost impossible to build in this country, for good or bad, because of the multi-layered regulatory process. So we absolutely must leverage the assets we have. And when we are building new assets, we better be able to justify it with a very transparent look. And moreover, I think we can reduce those long interconnection queues, which are a waste of time and a waste of money. And when we look at the climate change issues that we're facing, we don't have a lot of time. And we have to allocate those resources appropriately to get to the fastest, most efficient solution that brings value both to the issues of climate change, but also to our ability to manage our economy, our electric economy, very differently, and empower not only today's new generation, but also the electrification of cars and other aspects that we don't even see yet. And that's the real importance of building up that data. And I can't say enough about this, that somehow we need to begin to build a grid for a future that we can only see in part. We can only see in part what's happening with these extreme weather conditions. We can only see in part the ability of batteries to change the equation in ways we probably can't even yet measure. So we're not only building for today and maximizing the value of investments we've already made, we're building for a tomorrow that will be better, will be more efficient, will bring value to customers and bring value to our climate. So I think this is just the beginning, and I do hope that FERC moves forward with this NOPR very quickly as a beginning step in the broader look at our network so that we can build a network that is fit for purpose. As Europe has begun to do far earlier than we need to catch up and make sure that we're providing the economic backbone that we need as we recover from the dramatic events of the last year. So I just can't say enough about how important this is and how excited I am. And we'll get to the science. My wise colleagues can give you more detail, but from a broad policy perspective, this is almost an obligation that we have. So I'm excited to have more conversation about this. And with that, I'll turn it over to my colleagues.
Great, thanks, Nora. Just one quick question. I would encourage questions to flow, of course. If you're listening on the line, you can enter questions into the Q&A, and we'll hopefully be able to address many of them. But if we're not able to, we will follow up with answers following this session. But Nora, one of the things you mentioned about value to customers kind of played off the notion of having a more transparent grid. To me, I see sometimes a disconnect there where we know that at the end of the day, customers pay for inefficiency, but it's also difficult to account for that, to kind of take the challenges that exist at a macro level and kind of bring them almost down to the level of an individual customer like me. What do you think needs to happen to be able to make those links between what we see at the transmission level, these major things going on, but also make that resonate and make that more visible at the individual consumer level?
That's a good question, Alex. I think we need to look at the entire chain of communications, because I think that we miss a tremendous amount, not only at the transmission level, but we have disenfranchised the retail customer and many of the customers for whom this is critically important. So why we don't have fully functional meters everywhere in this country is just shocking to me. Even where we have newer meters, we're not developing the full ability of those to give data both to the user and to the provider. Those are not only economic choices, but those are choices of clean energy. I was stunned when I was a commissioner in Pennsylvania and we restructured our retail market to find so many people, for example, choosing green energy. And I think there's an assumption, and one that I find tremendously condescending, that customers either don't care about this information or are not capable of using it. Customers make buying decisions every day. They decide what kind of cars they want to buy, what kind of houses they want to buy. I don't understand why we don't think people are savvy enough to manage their own energy usage and energy choices. I also think that giving more information and having more transparency at every level, both for regulators, both for providers, both for users, will allow people to have more confidence in the decisions that we're making when we make big investments. I think right now we have NIMBYism, and I think in some part, that's because people don't understand what they're buying and what they're paying for. Not unlike the healthcare system, the energy system is the only place that you shop where you don't know really what you're buying and you don't know what you're paying for until after you've already bought it. I think that's just not healthy. It's not healthy for the discussion. I think it's prevented us from making good decisions about what we build and where we build. And I think it's critically important during this transition that we really have that data and that everyone be operating with a full understanding of where we're going. Does that mean everyone in the world wants to spend all day thinking about energy? No, but it means that a sufficient number of people are interested and will be interested and will engage in a more active consumer relationship that will facilitate not only their decisions, but the decisions of regulators and public policymakers. So I think data at every level, and I know in some places people are fearful of this kind of transparency, of getting second guessed, of market power issues. I think for those operators who are good, solid operators who care about the customer, and I think that's the majority, this kind of transparency will be welcomed, and this kind of understanding and partnership will be welcomed. And I look forward to the leaders in the utility sector to kind of show the way and to speak up on behalf of this kind of really critical development in a piece of infrastructure that's so vital to every part of our economy as well as our environment. Does that
so
answer your question,
Yeah,
Alex?
it's wonderful. Thank you. And again, sticking on this theme of transparency for a moment, and this is the last question I'll ask you for now, but this idea of transparency, I work with utilities on a daily basis, and I speak with the people who work across utilities, and I like this notion of transparency and the data that's being that flows, because I see the hard work that is done that oftentimes is unsung. It doesn't
Yes.
get the attention it deserves. I think if you start to think about the renewable industry that Chris will talk about in a moment, we see these very visible displays of windmills, of solar panels. I mean, just look at my background. But how do you connect that? How do you make sense of taking those electrons and moving them to the place that they're used? And that's a big challenge. And the work that's being done is significant, but it doesn't often get the attention or perhaps even the respect that it deserves. But I think there also is an incentive element to that. So Nora, in your opinion and in your background, what are some thoughts that you would have around arming regulators with really what they need to incentivize utilities to really help move us in the direction that we all know we need to go?
Well, I think it'll make regulators' job a lot easier, and I think, frankly, it will make the utilities' job a lot easier as they go in for rate cases and discussions. And I just want to say one thing in addition. You mentioned the people who do the work. I saw at PG&E 20,000 plus people who came to work every day under the most extraordinary conditions. I couldn't believe them. And I say that about all our utility workers. Again, and when you're in the field and you're in the trenches and you talk to these people, they are looking forward to having better data and making better decisions. And I saw the difference that technology made in helping us mitigate the effects of wildfires. And to me, that is a story that really needs to be told. And I think the same effect will happen in the Northeast, where we see more extreme weather conditions, the Midwest, wherever we are. I think it makes everybody's job a lot easier. But one of the challenges of being a regulator is, in fact, often trying to make decisions without adequate data, without having independent verification of data, without being able to measure outcomes. I'm a huge believer in performance-based regulation if you get the right metrics. And I think everybody wins in that. And I think this gives you the ability to fine-tune the regulatory process and allow people to make decisions, to make investments, and then to be able to understand clearly what value that has brought. Does that mean everybody is always going to make the right decision? Does that mean we have an excuse not to take some risk in technologies? I don't think so. I think there's a lot of ways to ensure the safety of the grid and the network while taking some quantum leap forwards in the investment in technologies. And again, the more data you have, the easier that is. This is a piece of it. Dynamic line ratings, I think, is a piece, but it also adds the value of the ability to get all other kinds of technologies and deploy those as quickly as possible to continue this advanced economy.
Yeah,
I hope that makes sense.
It sure does. So thank you very much, Nora, for those comments, and I'm sure we'll circle back to you in a moment. But thinking about really the reasons behind all of these changes, of introducing transparency, of the need to address congestion in the transmission system at large. I'd like now to turn it over to Chris Seiple, who has what I think are some very important thoughts around that subject, specifically as it relates to renewable energy, which is a big part of the challenge that we're facing right now. And Chris is another person who has a scary level of talents. And I think he's uniquely positioned for the comments that he's going to be making in a moment. He's currently the vice chairman of energy transition and power and renewables practice at Wood Mackenzie. But the reason he's so, I think, uniquely positioned is because looking back over his background, great depth and experience in energy research, but also financial and investment strategy. And really, he's also been on the front lines managing 2 gigawatts of generation assets. So talking about somebody who has really this perfect background for what he's about to say. And I don't mean to embarrass you, Chris, but I'll turn it over to you and take it away.
Okay, thanks, Alex. Can you hear me okay?
Perfectly.
Just to make sure. Okay, great. And if you could just go to the next slide. I just kind of want to build on what Nora was talking about and present this kind of in the context of how important transmission has always been important, but just how important it has become to decarbonization of the electricity grid. And the graphic that we're looking at here just shows the cost trajectory of different power generation technologies. And this is an average level for these technologies for the United States over the past 5 years and where we are currently projecting them to go in the future. And what's important to take away here, and pretty obvious, is that you can see even with the subsidies that we expect will be expiring over the next 5 or 6 years for solar and wind, they are the most competitive generation technologies available now. Being able to deploy renewables on a wide scale is no longer about the need for public policy support through subsidies and things like that. And in evaluating technologies like this, it's not just kind of the cost of competing technologies. The other important thing to look at is what revenues would these technologies receive from the wholesale power market if they were selling into the market. As you know, wind only blows certain times of the day. The sun is only available certain parts of the day. So it's really important to just look at those hours. But what we are increasingly finding is that not only is it, are these the lowest cost technologies, these technologies are also becoming competitive at current wholesale market prices, sometimes even in markets that don't necessarily need new capacity to be built. And this is really a change from where we have been over the last 20 years. And it is going to heighten the role of transmission. And I will talk about that in a second. So if you can just go to the next slide, Alex. This graphic is from a paper that we're actually going to publish next week. And this is just showing solar photovoltaic, utility scale solar photovoltaic systems in particular are becoming incredibly competitive now. The cost of solar has decreased over 90% in the past 20 years. It's amazing to think about the level of innovation that we have had in solar and wind technologies compared to the innovation that we have had in the transmission system, which is close to nothing over the past 20 years. And and the innovation in these sectors is not done. We project that just based on identified technology enhancements that are happening today in solar, costs are going to fall another 15 to 25% in the United States. And it is quite possible that there are innovations on the way over the course of the decade that haven't been thought of yet that could drive those cost declines even further. But what this is showing you is that in nearly, I believe, every region of the country except for Alaska, which was not part of our analysis, solar PV systems will be the low cost technology. In a lot of these markets, they will be lower than the wholesale cost of power. And that has two really important implications. The first important implication of that is that in the past, the amount of solar that got built or wind that got built was really a function of renewable portfolio standards, voluntary utility procurement mechanisms, and corporate buyers like a Google or Amazon who are signing contracts for new renewable supply and available transmission capacity. Now, really, it's quite possible that a lot more renewable technology can go forward just on the basis of merchant prices, wholesale power market prices, and competing with the existing technology fleet that's out there. So the availability of those other mechanisms is not necessarily what's going to hold back the level of development that we see happening in the future. And really, the most important ingredients that are going to influence, or factors that are going to influence what we see, is the extent to which banks are willing to accept that type of risk on these types of investments. Trading firms step up to manage those risks, and the availability of transmission. So transmission has really become a very important factor that will play an important role in determining the pace at which we see deployment of these resources and decarbonization of the grid.
Chris, apologies. Yeah. I just think it's a perfect time to ask a question that we have from the crowd here. So on that point that you just made, when we're thinking about variable ratings or advanced ratings technology, how do you think, or what do you think about with those ratings making future investments more justifiable than if we were using fixed ratings? So I guess what's the financial implication of variable?
Yeah. I think it's an interesting question. It's something that we are actually going to study and kind of do a complete analysis on at Wood Mackenzie this year. But at a high level, in a lot of the conversations that I've had with investors in the renewable sector, right now, when they're doing new deals, they are essentially putting in factors and just assuming that curtailment is going to happen to projects that they have, because that is, to a certain extent, what they have experienced so far, right? And I think that to the extent that you see deployment of technologies on the existing grid that help alleviate some of the congestion that happens, you're going to see investor groups reduce the burden that they're putting on projects and kind of the economic hurdle that they have to get over by reducing some of those curtailment expectations. Does that answer the question?
I think it does very well. And I guess a follow-up question that I have is, if you think about then, at what level of deployment of advanced line monitoring technology, we're talking about the FERC NOPR, any ideas at what level of I guess, integration into the grid would make a material change to how those investments are decided upon? So where do we have to go as an industry with advanced line ratings to make that material?
Yeah, I mean, I think as you're aware, advanced line ratings is just a part of the picture, right? A super important part of the picture, a really important place to start. But there's a number of technologies that can result in, improvement of grid economics and things like that. We haven't analyzed it to the extent there's a specific number or percentage number that I can, throw out and apply to you. But I think what investors are going to want to see, right, is first, really clear signals that this is either mandated or that the economic incentives are significant enough that they really believe this is going to go forward and this is going to happen, right? And then I think, like it is with many things, because the grid is very complex. I mean, the whole industry, one of the biggest problems right now in building a wind project, besides dealing with your interconnection request, it is figuring out how to price and manage the congestion between where you inject in a node and where your power is typically priced at, which is another point on the grid and a collection of points. And more the sponsors of the project, developers, are having to take on that risk. I think you need to see the certainties in the rules, but then people will also need to get experience and see it actually having an impact on the grid until they get comfortable changing the types of assumptions that they're working with right now. So, and speaking of this, so, you know, the, we need the investment in transmission. We need advanced technologies to get more capacity out of the existing system to continue to see renewables penetrate into the market. But this is a problem right now. And, you know, we have a team of 30 analysts in Boston who their role is to make daily predictions about where congestion is going to happen on the grid. And then to help people who own power assets who have exposure to that risk to help them manage that. And so we are seeing this on a day-to-day basis. And, you know, I just happened to be on the phone with one of our analysts and on a day where curtailment was happening. So this was back in early November last year. And, you know, you can see nearly basically the light blue lines and the light red lines show you what was expected to be produced and what was available based on wind conditions and irradiance conditions that day versus what actually went into the market. And you can see, you know, in this example, more than 20% of the availability capacity during certain hours is getting curtailed, is not getting into the grid. It's probably being met with fossil generation assets somewhere else on the grid. And, you know, you can see that like on this particular day, in this particular example, prices actually went negative in the western part of Texas at $4.90 a million BTU. So you had, or dollars per megawatt hour. So you had to pay to be able to inject power into the grid. And in the rest of Texas, prices were at $40 or almost $50 a megawatt hour. So differential of $50 a megawatt hour. So this is not like a future problem. This is a problem that we live with every day. And if you go to the next slide, you know, you'll see just a clear correlation. You know, on the y-axis here, we're looking at the level of price differential between West Texas and the rest of Texas. And on the bottom, we're looking at how much power was produced from renewable energy that day. And you can see a direct correlation here that as we are adding more capacity to the grid, investment in transmission is not keeping it up with it. And we are seeing bigger and bigger differentials take place, which is both negative from a perspective of dealing with climate change, and also negative from a perspective of the customer who's having to pay for the higher power on the eastern side of Texas. So, and you know, this is just one example. There are numerous places that this is happening across the country. So it's a problem now. If you can go to the next slide, Alex. This shows you what's happening with the interconnection queue right now. And, you know, as I said, renewables are becoming very competitive. In response to that competitiveness of renewables, the demand for corporate buyers to want to buy renewable power as well, there's been an explosion of projects in the interconnection queue that are waiting to be developed. And, you know, as I was saying earlier, you know, one of the biggest challenges now is going to be, is there adequate transmission capacity there to support these projects, and what type of, you know, what type of costs are put on individual projects. You know, a number of these projects have been taken out of the queue. We don't have exact numbers because they have faced incredibly high transmission costs that, you know, sometimes are as much as 20-30% of the cost of their overall project. So that has clearly become an impediment to some of these projects being able to go forward. And also, to my knowledge, I don't think for any of these projects, you know, we're at a point where the evaluators of these projects sitting in the ISOs are necessarily using advanced transmission technologies as part of what they're evaluating to make a decision on how much transmission investment is required for these projects. So that is another important part of kind of on the policy side of alleviating this bottleneck to getting projects done. So it's been a project. It is a near-term project. Our problem is a problem for these projects in the interconnection queue. And if you go to the next slide, Alex. You know, this is kind of our Wood Mackenzie's base case forecast, I guess, on how we expect new investment in the transmission grid to, or I'm sorry, not in the transmission grid, but in generation to take place. You know, this scenario that we are looking at here, by 2030, about 27% of all power supplies in the US will be coming from wind and solar, up from about 10% today. By 2040, this gets us to about 57%. This, if there are changes from a Democratic administration and Democratic Senate and House, this plan or the rate of deployment of new renewables could be advanced beyond what you see here. But whether it is or not, this is still an incredible amount of new power supply to be added to the grid. I mean, especially if you look at it in a historical context. We have never added this amount of capacity to the grid. And, this scenario is still only getting us to 27% of supply coming from wind and solar by 2030. So there's still a long way to go from this investment. Now, if you go to the next slide, Alex, in the fall, we did some work for the American Wind Energy Association to actually take this analysis of capacity additions that we were looking at and actually to ask the question, okay, if we wanted to accelerate it a little bit and, instead of getting to 27% of US supply coming from solar and wind, we wanted to get to 37% of US supply coming from solar and wind by 2030, what would be required in the transmission grid? And, our estimate was that it would require something like $70 billion in investment, an incredible number of large scale projects to be able to do this. And one thing that Alex didn't mention about my career was one of the things that I did do previously when I was an investor was build a project called Linden VFT, which was the first merchant transmission project in the world, increasing capacity between New York and PJM. And I think and this wasn't something that we even had to build a new line for. And I think the process of what it took to get to build that beyond just a lot of sweat and tears was something like 7 to 8 years of work for a relatively easy project to do compared to what these large scale projects are. So it's $70 billion and it's almost infeasible to a certain extent that we would be able to do all of the permitting, all of the regulatory work around who bears these costs on interregional projects and things like that in such a short time frame. And so, when you have advanced technologies that can be deployed so much more faster with scale, it really just needs to become a critical ingredient of kind of making the transmission investment that's required to deal with this congestion.
Chris, one of the things I think about is thinking about Nora's comments with the importance of transparency. The mandate, should there be a mandate from FERC to implement at a minimum ambient adjusted ratings. A big part of that isn't just that mandate. It's also the increased level of data and visibility and transparency that we're going to get within market organizers. Do you think that that information will have an impact on how transmission owners interface with investors or developers in terms of working to kind of clear out that backlog of projects? Is that data going to guide investment?
Yeah, I think it will guide investment, but also even more importantly, for markets to work well, you need transparency and you need data on what's happening within the market. The U.S. stock exchange would not work well without disclosure rules from countries and available stock market pricing, right? And it is the same way here, like for the market to work well, for investors to be able to make decisions, and probably even more importantly in this case, for somebody to manage their asset on a day-to-day basis. We need that type of information. We need that type of transparency. And the more people that have access to that information, probably the more opportunity for innovation that we will find in the industry as well. So that's our business, started Wood Mackenzie's with monitoring of power plants because people didn't have access on how much power was coming out of a power plant, right? Getting that information to the market was a critical part of building confidence for people who are investing and trading in the market.
That's great. Thanks very much, Chris. And I kind of like the path we're on here. Nora has shared a lot about really what this is all about. I think your presentation is great in terms of why this matters economically. And now we're going to talk with Rob Stephen about the how. So how do we do this? And a big part of that is figuring out really what these different definitions are, what ambient adjusted ratings are versus DLR. Rob, I'm sure everyone on the call knows as well, rounding out our list of intimidatingly sophisticated speakers here. Rob has extensive public utility experience with ESCOM. Rob lives in South Africa, as you can see here. And he's been able to leverage that frontline experience, and both with his business background, but also his PhD in electrical engineering for planning and design, and really just being a leader in his field. But I would imagine that the majority of us on the call recognize him from his work with his extensive work with CIGRE. He's still an active working group chair, and up through summer of last year was the president of CIGRE. So in terms of thought leaders, he's at the top. So I'd like now to turn it over to Rob for some thoughts on the technology itself. Rob.
Well, thank you very much, Alex. What I'll do here is just to cover very briefly a little bit of the background on static and dynamic ratings. We've been involved in CIGRE on dynamic ratings and static ratings since the early 90s, and many documents have been actually written on this, and it sort of had a ebb and flow about it, where people suddenly got interested or less interested in it. But I think the market development now and the constraints, as mentioned, has actually now brought this back to the fore. And really, it's something which is definitely technically feasible. And of course, if your constraints are thermal limits on the lines, of course, other constraints, you might get a stability, voltage, et cetera, et cetera. We're talking here about thermal limits. So if the thermal limit is your main constraint, then definitely there are means by which you can operate the line thermally, and methods by which you can actually then increase the thermal rating of the line. So just to go through this very briefly, if you look here at static rating determination, why we call it static, these are normally ratings which are on a fixed table. They do not change. And operators and designers know that on a certain conductor at a certain voltage, you will get this certain rating. So there you look at two different kinds. The first one is deterministic, which is really used largely around the world, where you select a set of weather parameters and calculate the current that will result in a defined temperature. That temperature is normally defined as a design temperature, or the temperature at which the conductor will be at the height above ground as defined by law. You might also have a temperature which is defined by annealing of the conductor. So it's really related to safety. When you select a set of weather parameters, depending on how you do it, your actual risk is not known because you haven't really done a probabilistic evaluation of that. But you're assuming either by past practice or other knowledge that the risk to exceed that particular temperature is fairly low. The next one that you might have heard is a probabilistic rating, which uses actual weather data, either on an hourly basis, depending on what you can actually get it at a lot more accurate intervals than that. And it determines the current based on an absolute risk or exceedance probability. This is used in South Africa, where we did a lot of development with that with CIGRE, and also in the UK, where they use a exceedance probability on their lines, and it resulted in uprating of the lines. Now, this is still a static rating because it'll give you a rating which doesn't change on the hour or by day. You can get a seasonal rating, but then the season is defined from a particular date. It's more complicated than a deterministic rating because now you've got to do a lot more computations. And with a probabilistic rating, for example, we use 30 to 40 years of data and most probably a couple of hundred weather stations around a particular country. So you'd need to be able to do quite a lot of computer analysis and then also relate that to a probability of an unsafe condition arising. And all this is covered within the CIGRE documents, which are now international documents. Next slide, please. If you now look at non-static ratings, and I've determined to call it non-static rather than dynamic, there's many different kinds. The non-static ratings, the one that you're looking at here is really an ambient adjusted. What you do there is if you've got a deterministic rating, and say you're assuming 40 degrees C ambient, and a certain wind and certain solar radiation conditions, if you know that the weather tomorrow will give you 20 degrees ambient, you plug 20 degree in with the wind speed and solar radiation, and you just calculate the current, which will result in your design temperature being reached with that ambient value. And the beauty about ambient is that it is fairly accurate, and the projections per hour over the days are fairly accurate, unlike wind speed, especially low wind speed. Your risk, though, is still unknown, and you may actually exceed your design temperature if your wind speed assumed doesn't materialize. So this is particularly important if you've got a very high wind speed that you've assumed in your deterministic ratings. For example, if it's around 2 feet per second or higher, the probability of that being reached all the time, especially in the evening, may not be realized. So you might have a risk there which you do not really understand unless you do some further analysis. So the aim here is to you can use the ambient adjusted rating, just be aware of the risk. The other one is the dynamic line ratings. And now this, you can actually use actual weather data, or preferably the location of the conductor. Now this is done in many ways, and there's a brochure out on real-time, what we call real-time monitoring within CIGRE, which defines a number of methods which you could do, and LineVision has got one of those methods. So there are a number of these methods which actually measure the conductor position in space. And then you use weather data to actually determine what that the current that will result in a particular conductor reaching the design temperature over the next hour, and you can actually go down to the next half hour. So this kind of dynamic rating can really help the operators to remove any constraints or manage constraints on a very short basis. You can also do longer term predictions as to the rating. Your risk is minimized here because now you're measuring wind speed, wind direction, and solar radiation and ambient temperature, and you're calculating the actual conductor temperature for a particular current, knowing all of those parameters. The important thing to know with any of the ratings is your sag to temperature relationship of the conductor. And when they install these particular devices, they will do a calibration to make sure that your sag temperature relationship is known. And you can't use the sag temperature relationship from the manufacturers because your conductor would have aged and had different loadings over time. So your creep rate and so on would be variable. So you have to actually do an online per line calibration. But once you've done that, you will most probably have a fairly low risk of in fact exceeding your design temperature. If we can go to the next slide. So considerations and actions. The request of FERC is ambient adjusted ratings will increase the rating under certain conditions. This is really what the aim here is, that let's try and get rid of these constraints, especially if they're thermally rated. There's a lot more we can do besides static ratings, which are normally deterministically determined, and that's 100% correct. Ambient adjusted ratings, which were in fact used by PG&E in the early 90s with the Atlas system, can increase the ratings under certain conditions. And your ambient temperature can be relatively determined for a time in the future. But we just need to be a little bit cautious here, as I said. If the assumed wind speed is high, design temperature may be exceeded, especially at night where your wind speed drops. So you need to just be aware of that. Your line may not reach a design temperature, but remember, yeah, if you're removing constraints, you're most probably going to be increasing the average loading on a particular line. So it's always good if you're looking at constrained lines and doing any form of uprating, especially this kind of thermal uprating where you're looking at rating uprating and not really changing conductors or anything like that. You need to actually, would be a really good idea to just look at and do a thorough investigation of the integrity of the line. Make sure you haven't got any damage to the conductor. or hot joints or anything like that. So because your average temperature could be higher, you might find your risk on failure of certain aspects of the line is also increased. So it's good to make sure that the maintenance of that line and the integrity of the line is sound. So that's the last point there. Just to check the integrity of the line and the actual design temperature. A lot of lines that we've found over the years is that if you actually do the temperature and you work out where is this conductor and how far is it sagging, you might find that, gee whiz, we thought we had a 9 or 10 meter clearance, which included perhaps a 0.5 meter buffer that we used. You might find that buffer is no longer there. Or you might find some areas where there's been some variation onto the ground levels, which has actually affected the height of the conductor above the ground. So it's always good to do these kind of checks if you're going to start using some kind of thermal rating increase, either ambient or dynamic rating. I think that's all really what I want to highlight, Alex, and I'll take any questions on this. We can, of course, go into any details on the different types of probabilistic and deterministic ratings, as well as many kinds of dynamic ratings and real-time monitoring. But in conclusion, I think what's happening here is the correct thing to do. And there are many ways you can upgrade the thermal rating of the line. And what we're looking here is monitoring systems and calculations, which will do that. Of course, you can increase your design temperatures by increasing the height of the conductor above the ground by retensioning and sound like that, which will also increase your thermal rating of the line. Thanks, Alex.
Thank you, Rob. That's excellent. I have a question for you from the audience that goes beyond the conductors themselves, but is related to ambient adjusted and DLR. Are you aware, or has there been an estimate of what substation devices, what impact they might have on the upside from advanced line ratings? Is that something that you...
Substation devices.
That's right. So limiting factors on substation devices that might have an impact on the upside of more capacity for...
Oh, yes. Normally, in fact, EPRI did quite a lot of good work on what they called it, a dynamic thermal circuit rating, DTCR program, which they introduced some years back. And there they looked at all the devices within the substation circuit, in which the line was a part, and you might have had cables and so on. But the ones to really watch is your line traps, which often have a very, they really can't exceed the current rating given to them. If you look at things like breakers, links, and so on, they're fairly sensitive, but not so much as of course, line traps. Lines, on the other hand, as I said, you must be careful looking at are they thermally rated, or is it which part of the circuit within the substation are you worried about? Because lines can actually be, the thermal rating can be increased if you've got a very low ambient temperature and you've got wind speed. You can actually go up to twice your static rating in certain cases. Now, you'll never do that on substation equipment. So you've got to be aware of what your limitations are within the substation. Normally within a real-time monitoring systems, if you use it on a line, we found the average is around about 10% increase on average. But you can get, it can go from minus, as you mentioned, to quite high above, especially if you've got a high wind speed and low ambient temperatures.
That makes a lot of sense, Rob. And, it actually triggered me to think there's a study from the Department of Energy that cites, and I hope I have these numbers correct, that a 5% increase in capacity reduces congestion 60%, and a 10% increase really nearly eliminates that congestion. So obviously individual circumstances apply, but the values that we're talking about seem to be of an order that would allow for that congestion reduction, even if there was the presence of limiting factors within the substation. Again, specifics apply.
As I said, you need to be certain that it's thermal rating limited. It's not stability or voltage limited.
Great. Good. I have to say, we have a lot of questions coming in, which is outstanding, but I do want to keep us to time here. So we will be answering your individual questions, and thank you to the audience for doing that. One question I'll leave with here, and you're going to think that I made this one up, but I promise I didn't. The question is, why is LineVision the choice to meet the NOPR requirement? And you know, in my humble opinion, I really think there are three reasons. The first, as I'm sure many of you are familiar, LineVision's technology is non-contact, and that's very important from a scalability standpoint. If we're having this mandated across all congested lines across the grid, eventually, the ability to deploy rapidly and efficiently is paramount, and that's what our unique non-contact technology can do. Secondly, thinking about the mandate for ambient adjusted ratings, we also have the ability to incorporate ambient adjusted ratings with validation, weather validation, like Rob was saying. The wind is the most crucial aspect of it. So incorporating that into ambient adjusted ratings is important. And then to Rob's point as well around understanding the current state of your conductors, the aging process, and what that might mean for potential clearance violations or the thermal capacity. Another application of ours is called Line Health, which allows us to assess the overall health of your conductor. So that's another feature. And I guess the fourth reason, I can't say that I count myself among this group, but we're a lot of fun to work with too. So that's the final reason. But look, I'll say I've been very impressed with all of the comments here. My gauge is if I feel smarter leaving a webinar, then it was a great webinar, and I feel a lot smarter, which isn't necessarily the highest bar to achieve for me, but really I think the content here has been amazing. So I want to thank Nora, I want to thank Chris, I want to thank Rob for their unique perspectives and really helping me and everyone within our audience start to make sense of this and think about what we need to do within 2021 to really deliver on the promise of a more optimized grid, because I think that's really what's at stake here. So again, thank you all for listening, for joining, and we look forward to continuing this conversation in other forums. Have a great rest of the day, everyone. Thanks very much.
Thanks.
And I can say you are fun, Alex.
I was thinking the same
Absolutely.
thing.
I can fake it for a while. Thank you, everybody.
Bye-bye.
Bye.
Bye.
Thank you. Bye.